All right, welcome everybody. What we're going to do today is we're going to review some of the types of reactions that we discussed last week on Thursday. And then I've got some information to help you with the lab that you're going to work on today as well. So I'd like to review the types of reactions that we talked about, starting with a synthesis reaction. So in a synthesis reaction, remember that you have one product. So if you can identify your reactants from your products and you identify that there's only one product listed in your chemical reaction, then that's an indicator that it is a synthesis reaction. So in other words, you've got a reactant and a reactant combining, producing one product. A decomposition reaction is the opposite in that you have one reactant. So that one reactant is going to decompose or break apart, forming two or more separate substances. So when you look at it, you've got one reactant and two products. So reactant AB broke apart into A and B, separated by a plus sign, so it's telling you that there are two separate substances. Here they are combined as one. Here they have decomposed, they have broken apart into two new ones. Okay, here's a look at a type of reaction where I've got magnesium and nitrogen gas yielding or producing magnesium nitrite. So I've got a reactant forming one product. This is a synthesis reaction. Okay, when I look over to the right here, I've got copper chloride producing copper and chlorine gas. So here I've got a reactant, product. So one reactant that's breaking down and forming two or more smaller products is a decomposition reaction. Okay, so let's take a look at a single replacement reaction. In a single replacement reaction, remember you've got an element, a compound, producing an element and a compound on the other side. Now, it doesn't have to be in the same order. It doesn't have to be element, compound, element, compound. It could be element, compound, compound, element. The key here is that it is an element and a compound on both sides of the arrow. So this is a single replacement reaction. Okay. So here it is again. I've got zinc plus copper chloride produces zinc chloride plus copper. I've got a reactant, a product, and a product. So that doesn't help me. There's not one reactant, there's not one product. But zinc is an element, copper chloride is a compound, zinc chloride is a compound, and copper is an element. So an element and a compound on both sides is a key indicator that it is a single replacement reaction. So what's happening is that zinc is kicking out copper, forming zinc chloride, and leaving copper all by itself. So it kicks out copper. All right. A metal, if you haven't already noticed, in our single replacement reactions, a metal will always replace, or no, excuse me, not always, but a metal will replace or kick out another metal to form a new compound. So a metal is able to replace another metal if it's higher up on the activity series list that's found on your reference chart. So if you take your reference chart, your blue or your white reference chart, metals here. All right, so that's the activity series list that we're referring to. Let's take a look at our double replacement reaction. So here I've got two compounds on both sides, and each compound switches partners with the other. So I've got a reactant, product, and product. So there's not one reactant, there's not one product, but I do have a compound, a compound, a compound, and a compound. So I've got two compounds on both sides of my equation, telling me this is a double replacement reaction. Okay, so what's going to happen is that silver is going to kick out potassium, and potassium will replace silver, forming potassium nitrate and silver bromide. Okay, let's talk about a combustion reaction. So in a combustion reaction, you've got the burning of a fuel, and that fuel can be a hydrocarbon, which is carbons and hydrogens bonded together. The reactants always include a hydrocarbon and oxygen gas. So this right here is my hydrocarbon, and here's my oxygen gas. The products of a combustion reaction will always be carbon dioxide, and water. Now you might be thinking, well, I've never been able to see water form when I burn something. Well, you're not forming a liquid because this is fire and fire is hot. That water forms as vapor, as a gas, so you don't really see it necessarily. Okay, the Bunsen burner that we use in our room burns a hydrocarbon that's necessary as my fuel, and that fuel is methane. And you remember that methane is CH4. When we burn our flame, we use what we call a non-luminous flame. So a non-luminous flame is a flame with two blue cones. So you want a blue cone inside of a blue cone. Okay, if you have any yellow forming, any yellow flame, that's incomplete combustion. Complete combustion forms when you have two blue cones, a non-luminous flame. Remember that the inner part of this flame is the hottest. Flip to the page that looks like this. It's the same page that had your list of polyatomic ions. Okay, the part that we're referring to here when we say the activity series is this box right here on the right. Okay, this is the box that we're going to be referring to when we're talking about our single replacement reactions. Okay, so what this shows us is a list of metals that are arranged in order of increasing activity. Okay, so you notice you've got a whole bunch of lists of metals and hydrogen. You notice it's in parentheses because hydrogen, even though it's not a metal, it acts like a metal because it has one valence electron and it tends to donate that, forming its a cation. So hydrogen is the only exception here, but it acts like a metal, so it's a list of, and they increase on the way up. So anything that is higher up on this list can replace anything that's lower or below it on this list. So for example, magnesium can replace aluminum, manganese, zinc, chromium, and any element that's down here below. Copper, for example, cannot replace anything that is above it on this list. Chromium cannot replace anything that's above it on this list. An element on here can only replace an element that is below it on the list. If it is above on the list, then no reaction will take place. Okay? So how do you know if you have a chemical reaction that's occurring? This is a recap, remember? Well, first of all, if you notice a color change. If two clear substances form a white substance, or two clear liquids form a yellow color, then that's an idea of a color change. That's a sign of a chemical reaction. If a gas is produced, if there's any smoke, fumes, an odor, bubbles being formed, that's an idea or an indicator of a chemical reaction. Production of a powder or a solid, sometimes it looks grainy. This is known as a precipitate. Okay, and you can see a precipitate down here where you've got a clear liquid and a clear liquid, but as soon as this liquid touches the container or the liquid that's in here, it forms a yellow substance, and it's hard to tell from this picture, but if you were to look at it up close, it would appear very grainy, very powder-like. It's a solid that's being formed between two liquids. This is a precipitate. Okay, if there's a change in energy, that's an indicator that there's a chemical reaction taking place. So energy can be in the form of light, sound, or thermal. So you can have an endothermic reaction or an exothermic reaction. So we're talking about an exchange in energy. So an endothermic reaction absorbs thermal energy and if it's absorbing energy, then it's going to feel cool to the touch. An exothermic reaction means that heat is exiting the substance. In other words, it's releasing thermal energy, and that substance is going to feel warm or warmer to the touch. Let's practice writing chemical equations from word equations. Some pointers that are given here, and I recommend that you look over them. If it's a diatomic element, a subscript of 2 is not part of the compound. Okay? So these are diatomic elements. These are elements that are found when they are by themselves, will be formed in pairs. They will be grouped together. So bromine will be by itself, it'll be Br2. Iodine by itself is I2. They pair up. Nitrogen is 2, chlorine is 2, hydrogen, oxygen, and fluorine. If any of these elements here are by themselves in a reaction, they will always be paired up with another element of its same kind, forming F2 or O2 or H2. They'll form or have a subscript of 2. If it's an ionic compound, you're going to use the crisscross charges, like we've practiced before. We have to use a plus sign. So words like reacts with, or combines with, or and, all indicates that they are separated by a plus sign. You'll use the arrow if it says yields, produces, forms, or makes. So let's practice here. Here I've got iron metal reacts with oxygen gas to produce rust, which is iron 3 oxide. All right, so iron metal is Fe. Reacts with, so that indicates that there's a plus sign, oxygen gas to produce rust, which is iron 3 oxide. So what is iron 3 oxide? Well, iron 3 is iron plus 3. Oxide is O minus 2. So when I cross the charges, I get Fe2O3. Okay? So is this balanced or not? Well, here I've got 1 iron, here I've got 2 irons. Here I've got 1 oxygen, here I've got 3 oxygens. So I can simply balance this equation by putting a coefficient 2 in front of iron. So now I've got 2 irons here and 2 irons here. I can add a coefficient of 3 in front of oxygen, giving me 3 oxygens here and 3 oxygens here. So now my equation is balanced. Okay, the next one says hydrogen gas and bromine gas react to yield hydrogen bromide gas. Okay, so hydrogen gas, hydrogen by itself is a diatomic element, so H2. And means that I'm combining it with bromine gas. Bromine is a diatomic element, so by itself it's Br2. Reacts to yield, so that's an arrow, hydrogen bromide gas. So hydrogen bromide, so H plus 1, Br minus 1. So when I cross the charges, I get H Br. So let's see if this is balanced. Here I've got 2 hydrogens, 1 hydrogen. 2 bromines, 1 bromine. So this equation is not balanced, and this one is, I don't need to do the box method unless you absolutely want to. If I put a 2 in front of HBr, now I've got 2 hydrogens, 2 hydrogens, 2 bromines, 2 bromines, and now my equation is balanced. All right, let's look at our next one. And it says aqueous hydrogen phosphate and aqueous calcium hydroxide react to form solid calcium phosphate and liquid water. So we've got aqueous hydrogen phosphate, aqueous calcium hydroxide, solid calcium phosphate, and liquid water. And then I see words like aqueous hydrogen phosphate and then reacts to form, and then I see and. So I see words that mean that there's a plus sign. I see words that mean that there's an arrow. So aqueous means that the substance is dissolved in water. So in parentheses, we're going to put AQ. Hydrogen phosphate. So let's see, hydrogen phosphate. I'm going to do this down here at the bottom. So hydrogen phosphate. So when I cross the charges, I get H3PO4. And we said this was aqueous, so AQ. And so at plus sign, aqueous calcium hydroxide. So let's see what calcium hydroxide looks like. Calcium is +2. Hydroxide is -1. So when I cross the charges, I get CaOH2. And this is also aqueous, so it goes AQ in parentheses. Reacts to form, so arrow, solid calcium phosphate. So let's see what calcium phosphate would be. Calcium is +2. Phosphate is -3. So when I cross the charges, I get Ca H3PO4 2. And this is a solid, so I indicate that with my parentheses. And my last one is liquid water. So we know water is H2O, and it's in the liquid form. There we go. All right, so H3PO4, aqueous hydrogen phosphate plus aqueous calcium hydroxide produce or react to form solid calcium phosphate and liquid water. There's my equation transferred from words, a sentence. Okay, so you'll be expected to know how to do these. If I give you an equation, you'll have to write it out in words, or if I give you a sentence, you'll have to convert that to an actual equation using symbols. So what I want you to do now is I want you to work on the types of chemical reactions lab. That should be a separate sheet of paper. Rewatch this video if you need to answer any questions. Pause it, rewind it, whatever you need to do.